right, so now that we have that out of the way, we're going to set up a smart object. So under the content folder, we're going to create a smart object folder. I'm actually going to call it smart objects. And then I'm going to add another one under that called bench. And then inside of bench, we're going to create a blueprint class of actor type and call it BP bench. And go ahead and open it up that. Now, the first thing we're going to do is go to the props, the prop bench RR mesh folder. We're just going to drag this into here. Another way would be to select it in here and then go to add and add a static mesh of type SM Street bench. It'll just add a blank one if you don't have a static mesh selected in your content drawer. And so if you did that and you didn't have it selected, it would be empty and you'd have to select it manually. So that's 3 ways to do that. Now we're going to add a contextual anim scene actor. And actually we need to add one of these to the character blueprint too. So let's go ahead and do that. Go to your third person, BP third person character, and add a contextual anim scene actor to it. And that's all we need to do. Compile and close. And now under here, we need to add a smart object. Under gameplay smart object. And I'm actually going to dock this under the bench, but I don't think it really matters. We're going to need a definition asset, but we can actually create it by selecting the drop down and select smart object definition. Another way to do that would be to right click and go to artificial intelligence and smart object definition. So however you want to do it, I'm just going to create it from here. I'm going to place it in the bench folder. I'm going to create a new one called, actually, no, I'm just going to place it under the bench folder. And we'll call it SOD bench. So let me just go ahead and delete this empty folder. You can go ahead and open it up and you'll see that it's empty. Now, if you go to the preview settings, you can directly set a mesh, or you can actually choose an actor class. I'm just going to add the actor itself, which is the BP bench. You can search for it, but I'm adding the actor because it'll be more accurate if I do it from the actor itself. So yeah. Anyway, getting started, I'm going to go ahead and give you guys a brief rundown. These are the default settings right here. If you set these settings on a per slot basis, they will by default override these definitions. You can have some control over certain aspects of that. Under advanced, you can change the activity tags merging policy and the user tags filtering policy. And that allows you to change it from override to combine so that it adds their user tags to the default user tags. Or you can leave it on override. If it overrides, that means that if you set these on the slots, then these defaults will be overridden. For the activity tags merging policy, I'm probably just going to choose combine. And so I'm going to go ahead and explain this to you. So a default behavior definition, this defines how this smart object reacts. So if you enable that other plugin, you'll have more than one here. So if you add an entry, you'll see that we only have gameplay interaction, smart object behavior definition. And that's because we didn't enable that other plugin, which adds a second one to this list. And for the gameplay interaction smart object definition, it requires a state tree, whereas the other one requires a different type of thing and it can't be ran on a state tree. And that's the reason why we enabled the gameplay interactions plugin so that we could use this with the state tree. The state tree gives us a little bit more control and functionality, as far as I know. And so that's the reason why. And you'll see that nothing shows up here, and that's because we haven't created a state tree specifically for this bench. So the user tag filter allows you to require a certain tag to be passed whenever the user interacts with it. And if the user doesn't pass the proper tag, then it won't be able to use this. It's kind of like a key or a password. The preconditions, just what it sounds like. So a precondition is a condition that must be met in order to use this. So I'll go ahead and show you what these two look like. So if we go to edit, it'll ask first to specify a root expression and a user description. And this is just the name it's going to show up as. And then root expression is, it allows you to match tags or expressions. I'm not real familiar with expressions, but I think all of you guys know what tags are by now. And so you can choose one of these, like all tags match, and you can come to the tags list and choose a tag. Now we're not going to actually be using these or these, but I'm just going to go ahead and show you guys how it works. If we add multiple preconditions, we can set it to and, or we can use or. So this would be this, if this is true or that is true. Whereas if we set it to and, then it requires both of them to be true. And then we can do the same thing here pretty much. We can match the runtime slot tags, match the object tags, the runtime object tags, or match the gameplay tags on the smart object actor. And this one is what it means by smart object actor. This is the smart object actor, whereas runtime slot tag is it's not the same as the activity tag, so don't get those confused. If we add a slot, you'll see they have runtime tags and activity tags. So whenever it says runtime slot tag, it's talking about these runtime tags right here. As far as the runtime object tags, I'm not even really sure what that means, to be honest with you. I'll have to revisit that at a later date. So that pretty much sums up those defaults. Now we can move on to the slots. So we have a name, a color, a shape. We can choose rectangle or circle. That allows us to make them stand out a little bit more. We can choose the size. We can enable it or disable it. If it's disabled, it'll be gray. We have an arrow coming off of it pointing in the direction that it's rotated. That's the forward direction of this slot. We have these runtime tags. These are tags that will pull up during runtime. So if we search for a slot using, so in 5.3, you can't do this yet, but in 5.4, you can search for slots by tag, and you have to use the runtime tag. If you don't have the tags set up on runtime, then it won't show up. I've already went over these, and setting these will overwrite these by default unless you change it from set to combine. So actually I don't need this to be set to combine on that, but I guess it's okay to leave it like that because we're actually not going to set up activity tags on this slot. We're going to set up a runtime tag for it. So selection preconditions, same thing. These are conditions that must be met in order for this slot to be used. Offsets and rotations, that allows you to offset it, and we'll go ahead and do that now. So I already kind of know where it needs to be offset to. I think it was like 65. And then this is like 45 up, 46. Okay. And then this rotation, I think is 90. Okay. Positive 90. Now we have data. This is custom data. If you want to create your own custom data, I believe right now you have to do that in C++. You would have to implement that in C++. Otherwise, you'll have to use these that are available to you, which is slot user collision, and you'll see it places a collision sphere. And the only option it has is use user capsule size, and that means that it'll adjust its own size to match that of the user. And this is basically if you need to disable the actual collision on the actor. This allows you to have some form of collision to prevent things from just going right through it while it's sitting on the bench. Then you have an entrance, and this allows us to add an entrance slot that we can access later, and that's what we'll do. And so I'm going to set 46 and negative 46 on this so that it's on the ground. That's not really important, I don't think, but I'm going to do it anyway. The offset on the X is going to move it in this direction, and that will be based off of the actual animation. So we'll go ahead and go and look at the animation itself. So find the bench enter C animation and open it up. We're just going to pause it and scrub through to the very end over here. And it looks like I actually failed to remove some of these false positives on this one. It's because of the way I have this set up with these docked on the side, and I had this open so I didn't see them. So if you have those, make sure you remove them. Those are false positives at the end. We only want them on the ones where they're actually stepping. So anyway, what we're trying to do is we're trying to scrub through to the very end, disable enable root motion because it won't show up if you don't, and then select the root. And so what we're trying to do is we're trying to get that Y offset on the root. We're trying to get the offset on the root. And if this is a significant value, which it isn't because it's like 1/1000th of a centimeter, and we're not worried about 1/1000th of a centimeter. And so we're not going to actually set that up, but we're going to use this offset for the entrance, and that will actually be the X of the entrance, not the Y. I don't know why that's the case, but it is. And this actually moves it side to side, as you can see. So if you did have a significant value on the X right here, you would add that to the Y here. But as you can see, it's not really significant. I'll go ahead and add it anyway, though, just for brevity. So you have a few options here. Is entry, you can disable is exit if you don't want it to be considered an exit. I'm just going to leave that enabled. It's not really that important. We're not actually going to use it as an exit, so maybe you can disable that. I guess I'll go ahead and disable it. Check transition trajectory. And this will basically, I think what it does is it won't allow us to use this slot if something is in the way between the entry and the slot. So if you enable that, you'll see the sphere going from the slot to the entrance, and you can adjust the height and stuff like that. So I'll go ahead and go over the slot link, but actually in order to use the slot link, we need another slot. And I don't think this functionality is even exposed yet to blueprints, so we can't actually even make use of this yet, as far as I know. Um, I'm waiting to see, but I've looked around to see if I can find a way to access that, but I haven't been able to. I don't know if it's broken or what. Maybe it's just not hooked up yet, or maybe you need to access this from C++ currently. Anyway, we're going to go ahead and add okay, we're not going to add a behavior definition because we have a default and that's fine. We're going to use the default up here, and we haven't even created the state tree yet. We're going to go ahead and add another slot here, and then I'll show you how to set up this slot link, even though it's not really functional yet. I'm going to make this a rectangle. I'm going to change the color. You can choose whatever color you want. I guess I'm just going to go with a reddish orange color, I guess. There we go. We'll just go with red. And I'm going to call this dependent. And I'm going to paste that there, but I'm going to invert this offset on the X here. And so the reason why the slot X and Y seem a little bit backwards is because it's relative to these slots. Their offsets are relative to these slots and not their position in the world. So we're going to go ahead and add an entrance to this as well, except I'm just going to shift right click on that entrance. And I'm going to shift left click right here, and it's going to paste all that for me so I don't have to set it up. So runtime tags, we'll set those up, even though we're not actually going to be able to make use of them yet until 5.4 is officially released. And those bugs that are preventing me from doing this from 5.4 are fixed. In particular, the ability to actually access the entrance location of the slots is currently broken in Unreal Engine 5.4 preview. So hopefully they fix that soon. Also, motion warping in relation to contextual animation, I have confirmed that is broken in 5.4. I'm hoping that also gets fixed by the time they release it from preview. Anyway, so moving on, now we're going to actually go ahead and set up the state tree. So save that. I'm going to Control Shift S to save everything. And then we're going to create a folder under here called state tree. And this is where this smart objects state tree logic will go. Actually, we could probably, I don't know, I feel like it's weird to place them under here like this. If you were to scale this up, yeah, we'll just do it like this for now. Anyway, if you want to organize things differently in your project later on, then do whatever makes sense to you. So we're going to create a state tree under here. So go under artificial intelligence and state tree. And this time we're going to select the gameplay interaction state tree schema. And we're going to say ST bench. So you'll see that we have more than one context actor now right here. And under the schema, we can set the smart object class, actor class, and the context actor class. It's not really important that we set these. And the reason why is because unless you need to access specific variables inside of here, then we don't need to actually change this from actor. And doing so would actually allow us to generalize this so that we can use it on more than one blueprint. But in actuality, in your game, you would probably have a master class, and so it would be fine to set this to the master class. In fact, though, I don't really see a point in having variables on here that we need to access from the state tree currently, and we won't be doing that on this setup, so we don't need to set that. The context actor class is the actor class of the character that's interacting with it. Again, we can leave this as actor because we don't need to uh, access any specific functionality on it. It may be the case that you could probably set this to a general character class, but it's up to you. I'm going to leave it like this. So in here, as you can see, we can access the smart object claim handle and the smart object slot entrance handle and the gameplay interaction abort context. Now, the one that's important is the smart object slot entrance handle. We cannot access this, as far as I know, outside of here, except in C++. So, also inside of here, we have tasks that are only accessible from the gameplay interaction schema. So if we come over here to the tasks and we expand this, you'll see all of these right here. And one of them is the find slot entrance location, which is really important. We'll be using that. That is broken in 5.4. That's the one I was talking about that was broken in 5.4. So anyway, that's basically it for now. I'm going to show you guys a trick that I use for setting up gameplay tags. You don't have to do this if you don't want to, but I'm going to. So if you're not interested in setting up gameplay tags like this, you can go ahead and skip on to the next one. So anyway, I'm going to create a new folder. I'm just going to call this gameplay uh, tag tables. And under here, I'm going to create a, go to miscellaneous and data table and type in gameplay, and you'll see gameplay tag table row and say OK. I'm going to call this GT Smart Objects. And the reason why I do this is because it makes it more portable. Also, if you want to update things, you can update them inside of this data table, and they will automatically update inside of your gameplay tag collection. So before these will actually show up inside of here, inside of this list right here, we actually need to assign this to the gameplay tag table list. And you can add multiple ones under here, and that's why I named this one GT Smart Objects. You might have a GT Smart Objects, GT NPCs, whatever floats your boat. So right now you're not going to see any changes in here, but as soon as we add one, it'll show up inside of here. Well, we haven't actually set it up yet. So there's a tag none here. So let's go ahead. The row names aren't actually important. You can assign whatever name you want to them, but I like to keep it consistent with whatever the last part of the tag is. So I'm going to create a smart object category, and then under that, I'm going to create a subcategory called types. You could actually call it object types or interaction types. Let's just call it interaction. Interaction, and we will call this smart object dot interaction. And then I'll shift right mouse button that, and we'll call this one sit. And then we'll create a couple more, and then that'll be it. So again, smart object, and this one will be sync. Now Control C that, and I'll call this primary. And if you want to add a comment here, this will show up in the tooltip whenever you hover your mouse cursor over the gameplay tags. It'll show up in that tooltip that appears, whatever the description is that you give it. And you can actually duplicate these as well. So if I save this and I come over here to the gameplay tag manager, you'll see we have this smart object entry. We have interactions and syncs, and then we have a set, primary, and secondary. And so if I say sync, let's see, let's just say I give it that tooltip and I come back over here. Then if I move my cursor over it, you'll see it says synchronizing slots. So that's how the comments work. Like I said, they'll show up inside of the tooltip. And now these are all portable. So if you want to migrate this to another project, you can. But then you'll have to go into the project settings of that one, and you'll have to add it as a gameplay tag table list inside of here before it'll show up in here. Anyway, now that we've done that, we're going to go ahead and set those as the runtime tags, even though we can't currently make use of it. And so for the first one, I didn't actually name that. So I'm going to name this as the primary slot. And you'll see it shows up right here. And as the runtime tag for the dependent, I'm going to choose secondary. I don't know why I called it secondary instead of dependent, but whatever. We can actually rename this, I guess, to secondary. So how the slot linking works is this can be used to, let's see, annotation to allow to find slots based on a gameplay tag. So in 5.4, right now in 5.3, this is not exposed, but in 5.4 it is, which was why I was wanting to use 5.4. Anyway, so you can find a slot based on the tag if it's linked to this. I don't really know exactly why we need to do this, but anyway, it does seem to work. I'll look into this more later, but the tag would be the tag of that slot, and it would be the runtime tag. So, yeah, that's pretty much it. I think I've covered everything as far as the smart object definition goes. So in the next video, we'll start hooking up the rest of the state tree logics. We'll create our own tasks and so on and so forth. I'll see you guys in the next video.